Welcome to this discussion of question 9 of the Cambridge AS Summer 2022 paper 3-1 discussion. We will do part A in two ways. The first is using the sin rule only, and the second one will be using the cos rule. The reason why the cos rule is probably choice of calculation is because we've got two sides and an included angle, but we will go the sin rule first because we need the angle A to calculate CD, so we're going to do that first. So to calculate angle A, we will use that the interior angles of the triangle is equal to total of pi radians, and we're going to subtract the 1,8 and divide by 2, and that gives us 0.67 radians. Now we can use that to calculate our outstanding side AC, and because it's a radius, it will also be the same as AD. Okay, so let's do AC over sin of 1,8, which will be the same as 6 over sin of 0.67. So that's using the sin rule. Using this C and 0.67, we rearrange our formula slightly to make it 6 sin 1,8 over sin of 0.67. So that will be 6 sin 1,8 over sin of our 0.67, which is a total of 9,40. Now we're going to use that to find the length of the curve. Now we could split this whole AD, which is also 9,4, into the 6 and the DB. You can see this side BC is 6, and then if we calculate DB, it will just come back to the total of 9,4. So the only thing we need to calculate is CD, and CD we will say is 9,4 times the angle, which is 0.67. And that gives us 6,31 units, 6,31. And it will be centimeters, obviously. I just want to include the centimeters. So our perimeter will be 9,40 plus 6,31, which is a total of just over 15. So that will be 15,71. 15,7 to 3 significant figures. Okay, now we can continue using the cos rule just to show that we get to the same answer. Why I try to avoid the cos rule is it's a bit more complicated in the sense that you have to take square roots and stuff. So it's a bit more calculation intensive. So I save a bit of time getting A first. But let's do it properly. 6 squared plus 6 squared. Then minus 2 times 6 times 6. Cos of 1,8. Okay, so that will be 6 squared minus 2 times 6 squared. Okay, which will give us 88,36, and that's on par to bring us equal to 9,40. Okay, so now we have the same length for AC, and all the other calculations will stay the same. We're going to now move on to the next part where we will calculate the area of the shaded region. And we will use the area of this triangle ABC, which will be equal to half times 6 times 6 times sin of 1,8. Okay. So, and that will give us 0.5 times 6 squared times sin 1,8, which is 17,53 units. And we're going to do the area of our sector ACD. So area of ACD will just be half of, now we're going to use 9,40 squared times the angle, because 9,4 times 9,4 times 0,67. Okay, so 5 times which will give us 29,64 units squared. Okay. And now to get the shaded region, we just say 29,64 centimeters squared minus 17,53 centimeters squared, which will give us 12,1 centimeters squared. Okay, so that's that one done. It's a quick 3 points. Just knowing that we have to get that sector, or that's area, by subtracting the sector from the triangle from the sector. Okay.